Why don't you guys introduce yourself? My app's not good.
So, this on? Yeah. Okay. So, welcome to the JFrog Swamp. This is a pretty amazing turnout here, and we are really happy to see you. And hopefully, you are enjoying your time in our little swamp. This is Untitled Chapter. He is a solution developer, and he gets to right now he gets to do fun things to do with JFrog X-Ray.
All right. Here's Mark Galpin. He's pretty famous in the community. He's a solution architect at JFrog.
And yeah. So before we get too much further, there was this talk about who's looking for work, who's hiring. JFrog is hiring. If you want to join this awesome team, there are people out there in the back who will be more than happy to talk to you about the many wonderful opportunities at JFrog. And certainly we'll be happy to have you on our team. But in truth, as exciting and cool and awesome as JFrog is, and it genuinely is, and I'm not just saying that because my boss is in the first row here.
My boss as well.
We're not actually here to talk about JFrog. We're here to talk about microservices. Because who isn't talking about microservices these days in the Bay Area, right?
Yep. And we'll also talk about data, and we'll actually do a live demo on how we can leverage each and every dimension of this data. All right, let's get started. So let's begin a journey to find a good monitoring solution for microservices.
That sounds like a long journey, but lots of people want it, so let's go.
Yep, all right. Okay, so yep. So there are different types of microservices, like product, third-party, stateful, stateless, ephemeral, and derived. Derived microservice is like I pick up an existing microservice, I give my own twist to it, and do a Docker push.
And it's important when we're talking about microservices. We all love microservices. They make development ever so much easier. But a single microservice doesn't solve a problem. That's why it's called a microservice. Yep. You need lots of microservices. They've got to be connected together. And together, they create an application or solution or whatever you want to call it that actually does something useful for your customers, whoever they are. It's an important point. But it only makes it harder. And it's important because every company is a software company. Now, here in the San Francisco Bay Area, this is not a terribly controversial statement, and especially probably not at a Kubernetes meetup. But it's worth noting, so I work for JFrog. For those of you who don't know, JFrog sells software tools that are really only useful for software developers and DevOps professionals. And that's, you would think, a fairly niche market. But you look at our customers, and our customers range from the retail industry, people like Nike, or the finance industry, or you name the industry, Major League Baseball. I was out at recently. And of course, many of the companies you all work for. I recognize many of the company names in here. But the point is, you name the industry, and they have a fairly significant investment in DevOps of some sort. And I know that because otherwise they would not be interested in our products. So that means that when we're talking about microservices and the trends in software development, this is something that matters to pretty much every company in the world. Even ones that aren't early adopters, they're paying attention to this stuff and asking these questions.
Yep. All right. And actually, every company is either creating or using a lot of microservices.
So we said microservices are important. We all care about them. But what are we going to do next?
Well, there are a lot of microservices. Docker is not enough. I don't know how I can hold these microservices.
So hopefully at this meetup, it's not very hard to guess the answer that, after you have Docker, you need orchestration. And the most popular orchestration tool, judging by the discussions I have with customers, is indeed Kubernetes.
Yay.
And so in case there's some people out in this audience that don't know what Kubernetes is,
All right, so we have a couple of microservices running on a couple of pods and a couple of pods running on a couple of nodes. It's easy to scale up and easy to scale down. All right, so we love this tweet. It's definitely not the reason why we moved from monolith to microservices. Mark, what do you think about the murder mystery?
so as you say, it's the downside, really, of why we moved. We moved because we like the faster development times, but the downside is that, yeah, it's genuinely harder to debug. And this is something that lots of people spend a fair amount of time talking about and thinking about. And I doubt this will be the most advanced discussion you're going to hear on this topic, but hopefully it'll contribute something interesting and new.
All right.
And one of the things that makes it hard is that the number of microservices and the number of binaries, the complexity of the architecture is just growing and growing and growing. Every single advance we do in software engineering comes at a cost. And that cost is that since we have more resources, we decide to use them. And it has great things, but in the end of the day, it's causing more services, more things you have to track, more things you have to understand, more things that work together with each other. And so the question, Ankush, is pretty simple. I've got lots of stuff. That's what a microservices architecture is all about at the end of the day. How do I monitor that stuff?
Well, let's take the monolith monitoring as a reference point. We'll do infrastructure level monitoring. Then we'll move on to service level, add a couple of health checks, and hopefully that should be enough.
Well, I really like this answer because I'm a big believer that, we have lots of great new ideas in software engineering, but we should be able to go back and apply the lessons learned over the last 50 some odd years to each new idea as it comes along. And so I'm really enthusiastic about this idea that we should be able to take, what we know about how to monitor a monolith and apply it to microservices. But I have to ask you, Ankush, do we think this is enough?
Well, container is a complex binary. There are two aspects to it. So what's inside the container and what's outside the container. Inside the container, we can have a couple of binaries from war file, jar file, JavaScripts. It has a build aspect to it. And outside the container, we have logging. We can monitor compute.
And, in the old days, these are two very different perspectives on what a container is. The developer is saying, okay, the container is this environment I build in, I deploy in. It's the place where my software runs. And from the ops guy, this container is basically a process that's using up resources on his server. But this is 2017. We live in the world of DevOps. Everybody gets to care about all of these things, which is cool, and it's important, and it's going to lead to much better software. But it does mean that we have to actually have the tools and the visualizations to do that. So, Docker images are layers. So, hopefully, here in this audience, I don't have to go at great length about how Docker works and what layers are. But let's just think a moment about what a classic Docker container actually looks like. So at the bottom, I'm going to have some sort of OS layer. Maybe Ubuntu or Alpine, or if I'm very brave, maybe I'm going to try to go off something like BusyBox. And then on top of that, I'm going to have some sort of framework. Maybe that's just a minimum set of Unix commands that a shell script needs to run, or maybe that's something heavier, like Java and Tomcat. And on top of that framework, whatever it is, I'm going to actually have my base application. So in my example of Java and Tomcat, that's going to be a war file. And this together builds up a container which can run a service. And it's how we've been thinking about containers for a while. But maybe Ankush, you've got a better way?
Yeah, let's step back a bit, right? So let's think it of as a graph, right? A component graph, where we have a couple of microservices. They may share a common Docker layer, right? They may share common war files, jar files, and maybe a JavaScript file. So if we find maybe some issue with the JavaScript file, it should be easy to correlate back to the microservice.
Okay. This looks pretty cool. And one of the reasons it looks pretty cool is that if I have a graph like this, there's some things that just start jumping out at me. If I'm starting to worry about like what open source licenses apply where, that's pretty easy to figure out if I have a list of all of the components and how they relate to each other. If I'm trying to find out whether a certain security vulnerability exists in my Docker container, again, I got this nice list of components, how they relate to each other. Pretty easy to figure that out. So there's a lot of really cool secondary data that I can scrape off the web or get from other reliable sources that I can apply if I have a component graph like this. But is there more data I can get with this?
Well, there is primary data as well. A lot of data is emitted in the CI/CD space that is either tracked on Jira or in spreadsheets, right? So why not we correlate this data back to the component graph? Let's, for example, like my security team, they identified some XSS issues in the JavaScript. Why not we can correlate it back to the component graph? Even the performance team, maybe they are monitoring the performance, the compute data, like the CPU usage. If it goes above a threshold, that's the performance issue, right? So we should capture and correlate this information back to the component graph. So all of a sudden, this is what it looks like. It's pretty complicated, I think. You have a couple of microservices up and running. We have nice graph of all the components, right? And we can correlate the primary data and the secondary data to monitor all or different dimensions of the microservices, right?
That looks pretty cool, but is it enough now, Ankush?
Well, we talked about primary data, secondary data. Hints? Anyone?
Yeah, well, I've been in this industry a while, and well, hopefully they're not quite as public as this one. Accidents do happen, and sometimes they are indeed as public as this one, as recently happened with AWS and their typo.
Yep. So there can be unexpected events like maybe a change of ownership executed in a database container, or maybe a typo, as Mark mentioned, causing a service to go down, right? Or maybe a wrong file picked up for production usage, right? So over here we are monitoring each and every dimension of the data available to us, right? Or maybe sometimes there are policies that, hey, maybe in my company a specific OS version is not allowed, right? So how do we monitor all the aspects of microservices?
Well, you know, this is lots of different angles, and it gives me, you know, hopefully a fairly comprehensive look at any given point in time. But I need a little bit more than just a look at one point in time. I need to look at all points in time. I need to be able to continuously monitor my systems as time goes on.
Yep, and there are new vulnerabilities found each and every day, right? And the compute data changes every day, right? So we should monitor all these microservices throughout its lifetime. All right.
So what should that look like?
Pretty complicated. Let's see. So we have an evolving component graph. It grows with time. It grows as the microservice changes. It goes as we keep adding the microservices, either third party or product, right? And we should be able to continuously correlate with either primary data, secondary data, and even events, right? And correlate back to this component graph. Like for example, if a jar file has a security issue, right? Or maybe I'm monitoring compute data in Kubernetes and I find a performance issue, I should be able to correlate it back to which service is being affected because of an issue.
That sounds pretty nice.
And these are the specs of this monitoring solution. It has to be a data aggregator, right? It should aggregate the primary data, which includes the monitoring data, right? And the secondary data is something which is already out there. Component graph, what do you think, Mark?
Yeah, no, I mean, this is a really critical thing. You know, there's no point in trying to build out a component graph unless it's pretty complete. And then I also see here we've got, you know, requirements to leverage data of other proprietary services. to do an impact analysis to further limit the damage, to link back to the source of the problem, and policy enforcement. So Ankush, you really going to manage to squeeze all of this into the demo?
Well, I can try, or the door is open all around. So let's do the demo. Whatever we have been talking about, we'll demo. So I'm going to start Minikube. One thing to keep in mind while we are playing with the Minikube is by default, it's very less CPU and memory is being allocated. So it's always a good idea to set the memory and CPU up front. And to confirm whether this works, all right.
Can you increase the size a little bit?
Sure. How's it? Good?
Yeah. Thanks.
All right. So my Minikube is starting up. I can talk about the services which we are planning to deploy. All right. While the Minikube is starting up, let's talk about the ingredients of our demo.
So the first ingredient is JFrog X-Ray. So for those of you who aren't familiar with JFrog X-Ray, JFrog X-Ray is a tool for doing some of that component analysis, for building out those component graphs that we were speaking about, and then for being able to tag those graphs with the sorts of issues we've been talking about. And then based on that, do impact analysis if a new issue comes in, see how that impacts all of the packages based on the component graph.
All right, the other ingredients of this demo is we are pulling data from X-Ray, which aggregates data from 6 other data providers like NVD or SNCC, right? And then since Kubernetes ships with cAdvisor, we'll be using cAdvisor to monitor the compute data, like the CPU, memory, and we'll go through cAdvisor as well. We are using InfluxDB to store this time series data. And then we wrote a couple of microservices for this meetup. So for the first microservice, what it does is it queries the InfluxDB, queries the compute data, uses a couple of mathematical functions like derivatives or mean, count, right? And say if the rate of change of CPU goes above a threshold, it fires off an issue and registers it in X-Ray. So that's our primary data. And then, of course, like all these services running on Kubernetes. So this is what it looks like. So I have all my services up. I have cAdvisor, which is getting all the compute data and storing it to InfluxDB. And we have a microservice which queries data. If identified, fires an issue in X-Ray. So we'll start 5 microservices in Kubernetes. I think it's less, but it's enough for the meetup. And then we'll monitor the running containers with cAdvisor. We'll flag performance issues with the custom microservice, and then report to X-Ray. And we'll also aggregate issues identified by both the primary data that we are generating and the secondary data, like known security issues or licenses. We'll correlate everything. And the data that will be used is to inform in the next sprint.
So one quick question, Ankush. We mentioned about accidents and other strange anomalous behaviors. How are you going to be looking for that?
Well, I actually I wrote we wrote like a quick integration with Sysdig. We just hacked our way around it. So Sysdig monitors system calls, and let me show you one cool thing as we speak. Sure. All right, so let me go back here. All right. So if we take a look at this Docker file, right? So we start with something basic like Alpine, right? Like this stuff can be delegated to CI, but over here we are only installing packages what we want, right? So if my service is up and running, we can use sysdig to capture these events, right? Maybe a microservice is running and maybe a wget is being installed, right? So for those kind of things, we can use sysdig as well. We'll demo some part of it. We just hacked our way around to demo just the core stuff, that it's very, very easy to pull data out of sysdig. So this is another primary source of data. All right, so looks like my Minikube is up. Let me make sure whether it's functionally up. Okay, perfect. So I have a couple of services running. My dashboard is running on port 30,000. All right, perfect. It's all empty, looking good. I'm creating two secrets because I need to fetch my microservices from a repository. We are using Artifactory in this case. Let me create these microservices. So InfluxDB, the deployment and the YAML files. Okay, let me check whether it's up. Okay, perfect. It's coming up. So if you look at InfluxDB, again, it's pretty simple stuff. It's fetching the image from this repository. We have exposed a couple of ports. We created a database which is created by default. And this is the service file. It allows us to scale up and up. All right, let's start other services. Config maps, if you have a configuration file, it's the YADL way is to create a config map and then link it back to a microservice by volumes. Okay. All right, let the magic begin. So my services are starting up. Over here. All right, my InfluxDB is up. Let me update the port for the UI to work. So it created this table, which can store the compute data. And C advisor. Okay, I think just a bit bigger this time. Okay, let me use the font. Okay, perfect. This is reflected in all tabs. It's nice. Let's see if C advisor is doing this trick. Not yet. Perfect. So my C advisor is up. What it does is if we have a couple of microservices up and running, it monitors CPU, memory, file system usage, shows nice graph, but that's not the point. the beauty of it is we can even monitor at the container level. And the microservice that we wrote, it correlates container with the corresponding Docker image. Let's see this. So this is the monitoring data for this container. Okay, perfect. So my C advisor is able to push all the compute data from CPU, file system, memory, everything to InfluxDB. And let's see if our plugin, the microservice that we wrote, is working. All right, cool. So it's able to find an issue with this. So it's able to correlate back like a container, correlate back, figuring out how does it correlate with the corresponding Docker image. In this case, if the rate of change of file system usage, if it went above a threshold, is gonna report it as an issue. So let's see. If this issue shows up over here. All right, I can see this primary data coming from C advisor. Sure.
Yeah.
Is good? Perfect. So this is a custom alert coming from C advisor for this Docker image. So it's able to correlate a container with the corresponding Docker image. We just add a lot of metadata as well. Like for example, in this case, if the rate of change, file system usage went above a threshold, we're gonna fire off an event. So that's the primary data. And let's look at the secondary data. So this is the component graph that we are talking about before. This is the top level Docker image. A couple of layers. It's a complex binary. If we look at this layer, it's able to pull the data from secondary data providers as well. So the data is already there. We just need to correlate every aspect of a microservice, right? So over here, it shows a list of all the known vulnerabilities for this layer itself, pulling from sources like NVD or SNCC. And there are other data providers as well. And it also figures out the license. Again, this is all known information. So it's figuring out license of each and every component used. If it's not able to find, it's going to say unknown. But it's able to correlate the primary and the secondary data with the component graph. So if an issue, for example, is part of this args4j, we will be able to know that what all files are affected, what all components are affected because of this. An easy example. Let's go with Alpine. Right? Perfect. So this is my layer. Now, if, for example, if I'm monitoring this using C advisor, and I found some issue with this Alpine image. Now, how do I know what all microservices are being affected, right? Or maybe there's a secondary data. I came to know that, hey, okay, there is some issue, security issue reported. How do we know what all services are being affected? So over here, at least what it shows me, that this image is used by these many services, right? So it is able to create the component graph. All right. So let's try the other integration, which is the sysdig integration. So again, for the meetup, we just hacked our way around to create this integration. So in sysdig, there is sysdig cloud. So there's an agent which is deployed next to running microservices. It gathers all the data, pushes to sysdig cloud, and then again the thresholds are set over there. If there's some event, I just wrote a simple Node.js. It's simple container. It looks for sysdig events, goes through the data, and reports it. The reporting part I'm not done, but what I'm trying to show is it's very, very easy to fetch primary data from multiple data providers. So over here I have this integration service up and running. Okay, let me get the port. All right, cool. So as you can see, it's very, very easy. So in this case, the source provider was SSD Cloud. This is the issue we are forwarding as is, along with the severity. And it's also able to correlate a container with the corresponding Docker image, right? And these were the metrics used why the issue was fired off. So like in this case, the average CPU was above 1. We lowered the threshold for the meetup. But the idea is that it's very easy to capture data from multiple data providers, whether it's say sysdig or cAdvisor, and then we already have secondary data out there. And we collate, we bring it all together and correlate it in the component graph and do the impact analysis. So yeah, that's pretty much the demo. All right.
So that was pretty cool stuff. I at least think so. And so just to kind of summarize kind of where we got to with all this, not collecting data is going to leave you with a murder mystery you can't solve. It really is, it's a crime if you're in production to not be collecting good data on what's going on inside your containers. And one of the reasons for that is it's not actually all that hard to collect data. There's great tools like cAdvisor out there that can reach into a Docker container non-intrusively and at least collect the sort of basic metrics that you've always been expecting to collect on a machine, and usually you can get more as you need to. But the trick is, first you have to collect the data, then you have to do something with it. And so a tool like X-Ray can aggregate that data from many different sources, primary, secondary, whatever type of data you have, and it will help you make an informed decision. And an informed decision can be something you have to do live, but just as often it's something you have to do in your next development sprint of how do I make this better for next time. And that's really the heart of DevOps is, you release something, you get to see what's actually happening in production, and then you make it better. That's what we're all about. So before we move into the Q&A, just want to mention also, hopefully you're enjoying our wonderful swamp. But if you want an even better environment than this, I know it's hard to believe they exist, but they do. Napa Valley is definitely that place. So feel free, please come out to Swamp Up. Tickets are on sale now. It's going to be a great time. I do not know anybody who has gone to Swamp Up and regretted going and not wanted to go again the following year. And I know quite a few people who have gone to Swamp Up. So, take that for whatever it's worth. And with that, we'll turn it over for Q&A.
Questions? Anybody has any questions?
How would tracing data get integrated into this?
Sorry,
Tracing data,
tracing data.
yes.
How would tracing data get integrated into this?
Oh, there's a REST endpoint that we used. So like tracing data, you're talking about like any data, compute data?
Do you know what tracing data is? Looking at, as you call through a stack of microservices, when each one got the request, made child requests, the child request satisfied, and it released back.
Mhm.
So gathering that across a query, you get a chain reaction, and it collects that whole set.
Got it.
Zipkin is one of the well-known
Yeah.
ones, but things like that, where you're gathering all the different pieces that it takes to satisfy a single request across all your microservices. How does that, which is trying to pull all that together, tie in with this?
So, I mean, at this point, we're
Mark,
more
can
focused.
Can you repeat?
Yeah. Yes. So
Okay. So tracing allows you to gather all of the microservices that go together to satisfy a request and shows the timing of them. And so I'm asking, how would that kind of timing type data where you're looking across that set? And it's a very powerful thing to find the,
Yep.
the problems that are, okay, X is slow, who's the bad guy? Tracing is one of those key tools for it. So I'm wondering how that would flood, not so much how you would get it in, but how it would be useful within this context.
it's a good question, and like many good questions, it doesn't necessarily have the greatest answer in the world. But I think, one of the things about that is that at the end of the day, you identify a bad guy, right? And so once you've identified the bad guy, whichever service it is, then you want to flag, and then you can attach that data and say, okay, this is why. It's not just a matter, when I'm a developer, I don't want to just get a bug report that says this service is too slow, right? That's not, raise your hand if you've ever gotten a bug report like that. And how many of you considered it useful? Right? So the point of a metadata service like this is that you can attach detailed data to the right component. And what tracing is helping you do is identify what is the right component to kick and say, hey, this one needs to be improved.
Any other questions?
Good luck getting the mic to him.
Does JFrog have any solutions for this?
So you said that you had the graph of components in the JFrog. What exactly you use inside to track that?
So the graph is, so we go layer by layer. We decompose it like layer by layer and then create a graph out of it. Right?
And where you store that? Is it some special database?
Yeah, database. We store we rely on Postgres. All the graph data is stored in Postgres.
So it's only Postgres?
Yes.
MySQL?
Not yet.
Okay.
Yeah.
And second question, so let's say that you figure out that one component was compromised and you decided that, okay, I would like to find that application that I'm running right now that compromised as well.
Yeah.
Okay, you figure out that, and what next?
So, then you have to do something about it. And, when I was a kid, of course, you watched G.I. Joe commercials, and it was knowing is half the battle. So we'll start with that. But there are tools out there that, once you've designated that there's an issue, they can suggest remediations. So, for example, one of our partners is Sneak, and they have a set of auto pull requests that'll happen if you identify an issue with, say, an individual Java library or Node library, and it's fixed in the next version of that Java library. They'll actually auto-generate a pull request to update your dependencies to go to that next version of the library. So there are starting to be auto-remediation is starting to be a thing. I think it's a very, very baby field. At the end of the day, this is, probably another one of the great next applications of AI. In terms of then what, today mostly then what is you generate a ticket in Jira for a developer to go fix it. But we're all looking at what are the sort of automated remediations that you can do as well.
Plus, apart from that, we can easily, once we know an issue, we can cut the damage, right? What I mean is, like, if you see the Docker file, we are getting that binary from somewhere else, right? If we identify that the binary has an issue, we can block the download for that binary. So the issue is not spread all over the place. So typically, like say for example, if you have Kubernetes running on staging, you're doing monitoring data, it goes through one set of tests, right? Then you know all the issues. And in the production instance, you make sure that none of the Docker images which have issues tagged to it, they are pulled on a production version of Kubernetes.
Okay. Another question.
Okay, we are running out of time. Thank you, Mark. Thank you, Ankush. I know. That's why I'm turning towards you and looking at you. We are running out of time. Both the questions took a lot of time, but we don't have a third speaker, so we have a lot of time at the end. And I request you guys, the speakers will be available after the meetup, and you can ask more questions, detailed questions. Even I have questions. All right. Thank you, Ankush. Thank you, Mark.
Thank you.
And while the speakers are changing, I am Dawal. It seems someone told me that I did not introduce myself. So I am Dawal. I am one of the organizers for the meetup. And I am a DevOps engineer. Kubernetes is my passion.